Okay, in this video, we're going to look at radical equations. So we've looked at operations with radical expressions. So the next natural goal is to learn how to solve these equations which have radical signs. And note, always verify a result because square roots or even other roots of even roots, let's say, give multiple answers. They may not all be valid. For example of an ambiguity, start with x equals 4. Now square, x squared equals 16. So x squared minus 16 equals 0. X minus 4, x plus 4 is 0, giving me x equals 4 and x equals negative 4. Now that's an ambiguity because I started with x equals 4 and now I have two answers for x. So be careful, and that's why we need to verify our results. Example, root of 2x plus 3 is 5. We get rid of the square root by squaring both sides. Alright, so I end up with 2x plus 3 equals 25, 2x equals 22, x equals 11. Let's look at this example. Squaring both sides, I have square root of 3x plus 4 squared is 8 squared. That's 3x plus 4 is 64, 3x is 60, and x is 20. Let's look at this example. I have to do a little bit of work right before this. So I have x minus 3 equals negative 1. Root x minus 3 squared is negative 1 squared. It's x minus 3 is 1. So x is 4. Now let's go back and verify these two results. Verify 3 times 20 plus 4, that's root 64, which is 8. So we're good. 4 minus 3 plus 6, that's 1 plus 6 is 7. That's not equal to 5, right? So this is not a solution. So there is no solution in this case. Okay, so this is where verification becomes important, because when we square or square root stuff, there is a possibility of an ambiguity occurring. Minus 5 square, I get squared equals negative 5 squared, which is 25. I get x equals 26. Now when I verify, 26 minus 1 plus 7 is root 25 plus 7, 5 plus 7, 12, which is not equal to 2. So there is again no solution. The reason this is happening is because when we square this negative 5, we're losing some information and it becomes positive. Right? So this could as well have been positive 5. In fact, if it was positive 5, it would have worked out fine. Let's look at some more different kinds of examples. Now in this case, there is an x term in the radical and outside. So the strategy for this is to isolate the radical. Once you've isolated the radical, and then you can square it. When you square it, you're going to end up with an x squared term over here. So you can get rid of all the terms on the left side and add it to the right side. So you get 0 equals negative 10 plus x squared plus 3x. Or in other words, I have x squared plus 3x minus 10 equals 0. Now that's a trinomial which you can factor as that it gives you x is 2 and x is negative 5. But now you gotta verify. Let's say this. Verify. First, let's use 2. 2 plus root 26 minus 22 is 2 plus root 4 is 2 plus 2 is 4. So 2 works. What about negative 5? Negative 5 plus root 26 plus 55. That's negative 5 plus root 81. It's negative 5 plus 9. That's 4. So that works too. So x equals the set negative 5 and 2. Now here I have a cube root. So again I isolate the radical term and now I cube both sides. Okay, when I cube both sides I have 1/3 and I have cubed is negative 4 cubed. That's 3x minus 1 is negative 64. So I get 3x is negative 63 and x is negative 21. Let's verify. 3 times negative 21 minus 1 to the 1/3. That is negative 64, which is negative 4, and plus 4 is 0. So that is my solution. Now the last type is where you have x terms in the radical on both of them, right? So here, what you want to do is maybe isolate one of the radicals and send the other radical with a rational number on the other side. And then you square both sides, because that way you get rid of at least one of the radical completely. The second one you will not be able to get rid of completely because you're going to have a 2 root x plus 4 term. But now you can convert this into something that we have seen before. Namely, now this is a radical on one side and no radical on the other side. You can be a little smart here and see that the 2's can be cancelled before you square. So x minus 2 squared is now root x plus 4 squared. So x squared minus 4x plus 4 equals x plus 4. Subtract, subtract. So I have x squared minus 5x equals 0. X times x minus 5 equals 0, giving me x is 0, or x is 5. And now all that left to be done is verify. When x is 0, I have 3 times 0 plus 1 minus 0 plus 4. That's root 1 minus root 4. That's 1 minus 2 is negative 1. So no, 0 doesn't work. What about 5? I have 15 plus 1, 5 plus 4, root 16 minus root 9, 4 minus 3 is 1, so that works. So the only solution is x equals 5. So this is why the verification is important, because even if you solve and get an answer, it may not be the right solution. That's the end of this section.